For this week, we will explore classifications using the decision trees algorithm, clustering using the k-means algorithm, and be exposed to various cloud machine learning services. When working through different activities, we are supposed to experiment with different aspects of decision tree, random forest, and k-means with the Jupyter Notebook environment. You are welcome to share with other students and tutor your findings during your tutorial sessions from the activities. For activity 1, we are going to discuss regarding the classifications, decision trees, and random forest as two examples. For activity 2, we will discuss regarding the clustering and k-means algorithm as an example. For activity 3 is optional. You are welcome to explore different cloud services such as GCP, like Google, Amazon, Azure, Aliyun, data robots. Now, let's start for our activity 1. For classifications, for this week, we are going to start with classifications, which is in machine learning. It is part of the supervised learning style. You may refer to your lectures in week 5. For supervised learning, usually we have the training and testing datasets. However, for our unit, we will look into the validations of datasets. For this activity, first, we will be attempting to predict whether a person has traveled abroad based on the person's age and income. Now, let's start with the usual importing of the necessary libraries. First, we will start from the NumPy, Pandas, Matplotlib, and to read our file. Kindly make sure you have already opened your notebook for you to key in your code. Once you key in your code for libraries, we can take a look for your dataset. Normally, we will investigate the content of a dataset through their shape and the first 5 entries. Here, you may take a look. The dataset should have 400 rows and 3 columns. The columns should be age, income, and travel abroad. This is a record of past incidents or survey data. As the intention is to build a model, we are going to use this as the training data. For your practice 1, if we use the whole dataset as the training data, how do we know how good our model is? Our answer is, usually we reserve a smaller portions of the dataset to act as a test data. Since we know the output of the test data, we will then be able to determine how accurate is our classification. We will proceed to split our dataset into the input data and their corresponding label data. The first 2 columns are the input data. For example, the age and incomes of which we would like to predict if the person has traveled abroad before. For the past survey data collected, we have some samples, and this travel abroad is the respective label data. Let's split our data into X, the input data, and the Y, the label data, by using the following commands. As mentioned before, we need to reserve a portion of the dataset for testing data. We can either simply take a portion of the data, or a better way is to take a random sample of the data. We can use the function train_test_split functions from sklearn model selections. Now we are moving on for feature scaling or normalizations. Since the range of values for the raw data varies widely, in some machine learning algorithms, objective functions will not work properly without a feature scaling, as known as normalizations. For example, many classifiers calculate the distance between 2 points. If one of the features has a broad range of values, the distance will be governed by these particular features. Therefore, the range of all features should be normalized in order for each feature to contribute proportionately to the final distance. In addition, our motivations here is to visualize the feature space later on. The above paragraph may be difficult to understand, and it is for you to try to search online to figure this out, or to share with us what you know about it through the forum or informally through Slack. We will use the built-in function standard scaler from the sklearn preprocessing to do this. We apply the fit transform functions to the training dataset and not the test dataset. The reason is that we want to scale it to have a mean of 0 and a certain standard deviations. The mean and standard deviation value will be stored in the standard scaler functions and applied to the testing dataset using the transform functions. Now, our data is ready to be used to build the model. In reality, we will usually need to read and wrangle the data before we even start to normalize or standardize the data. As usual, we import the standard scaler from sklearn. Our classifier is the decision tree classifier, criterion entropy, random slip 0, and we will use our model to fit our training x and y. Normally, when we want to build a model, most functions will have a method called fit functions. At the end of running that code, we now have a model using a decision tree algorithm, and the model is called classifier. Since we now have a model built, let's test how well our model is. First, we use the build model with the testing input data, not the labels. We use the method predict in the model. This method is also quite common with other built-in functions for models, but they also call it as prep. When we execute this line, our yprep, we now have a set of labels yprep, and this is the output from the predictions by using our testing data. We now need to compare this yprep with the actual y-test, the true value, and determine the accuracy of our model predictions. To do so, we want to build it using a confusion matrix. It was covered in your lectures. This is an important concept for classifier comparisons. To make our confusion matrix, for your practice 2, from the confusion matrix output, what are the values of true negative, true positive, false negative, and false positive? And other than accuracy, would precision or recall be a better measures for this particular case? You will need to recall your memory of your confusion matrix. In short, if you match with your confusion matrix boxes, this one is your true positive, and this one is your true negative. This one is your false positive, and we will take this opportunity to introduce a new visualization called the mask grid. For this demo, we will look at the test result in the feature space. You do not need to know the syntax or how it works. This is just for illustrations. It is optional. We visualize the test set result, import the listed color map. We set our x, y to our test x and y test. We use a mask grid with the arrangement, our contour, the parameters for us, the x limit, y limit. This one is for our scatter plot. And we put in the title, label for x is age column, for y is income, a name for the XY label. We plot our legend and show. Here, if you take a look, we will proceed to train and test using a random forest algorithm. Another classifier, aside from the decision tree, is the random forest algorithm, which in essence consists of multiple trees, each based on a random sample of the training data. Usually, they perform rather well. Let's now fit a random forest classifications to our training set. The concepts are similar to the above. It's just that we're using a different model. All the data reading, splitting, normalization has been done above. Now, we will proceed to fit the random forest classifications to the training set. First, we start from sklearn ensemble, import random forest classifier. Put our parameters, our estimated 20, criterion entropy, random state is 0, and to fit on our training data x and y. Perform the predictions using the predict functions. Once we make our predictions, we will proceed for the confusion matrix. From sklearn, import our confusion matrix. And based on our testing data and our predictions, for your practice 3, we are supposed to discuss the result of the above confusion matrix and what is the accuracy, and make the comparison with the previous decision tree result. In machine learning algorithms, one way to improve your test accuracy is to tune the parameters. For example, your number of trees in your random forest algorithm. Tuning based on the parameters of the model building is called hyperparameter tuning. You can try the above code using the n estimator equal to 40. You can also visualize your test set result in the feature space. From your matplotlib, you use the listed color map. Put in your test parameter for your mask grid, your contour, your x and y limit, plot the scatter plot. Put in your title, x, y label, your legend, and to show your graph. Like this.